Welcome guys. So this video is just trying to prove this problem. Basically, if you can see, basically it's an advanced analysis problem. Okay, so sine exponential t dt from x to x plus 1, take absolute value will be less than 2 divided by e e to x. Okay, so in the beginning that this integral is hard to do, right? So I would guess that I just let exponential t to be, let's say, y. Okay, so the original integral just basically just sine y, right? So dt exponential dt will be dy, right? So will be dy divided by y, right? So this integral is very famous, and our integration will become this, right? But how do we prove this, right? So if we can take the absolute value, and okay, so before we do the absolute value, maybe we should quickly try something special, right? So we start from here, and that's that we do the integration by parts. So this is d minus cosine y. So we got the minus cosine y plus cosine y, and the derivative of d derivative of 1 over y, so it's negative y squared dy. And then we start from exponential x plus 1, exponential x plus 1. Right, so the first term will be minus exponential x plus 1. Okay, so before we do it, so we see these are two terms, right? So the first, if we take absolute value, right, and this term will less than, so remember that the cosine y is less than 1, right? So if this first term will just less than 1 divided by exponential x plus 1 over exponential x. Right, there's minus term, right? But I can replace it by plus term because I use absolute value. And also the this term, this term is basically, okay, so it's less than right, less than this. Okay, so let's change a little bit. Let's focus on this term, right? So this term will less than only this blue term, right? Will less than y squared dy exponential x plus 1. So this is minus exponential x plus 1 plus exponential x, right? So if I add the term, this term and this term, I just add it up. Okay, I will get a beautiful answer. Okay, so that's it. Right, so basically we just separate into two terms and do the sum trick. So we only need this one and the partial integration by part. Okay, that's it, and I will see you guys in the next advanced calculus videos.